All right, here we are at lesson 1.2c, similar polygons. Polygon ABCDE and polygon FGHIJ are similar polygons, and they've told us that. Now, there's supposed to be a rule where if you're labeling your polygon starting with A and it's going around clockwise, you're labeling the second one the same way starting at F, that A and F, or sorry, the distance from A to B and F to G are supposed to be corresponding. Okay, so assume that that's the case unless you're looking at your drawing and you're going, yeah, no way is that correct. Okay, but on this one, these look like the same shape. They look like they're oriented the same way. So I'm going to color them accordingly, and I don't have a color for the last side. Okay, so knowing that and knowing that it seems to be labeled correctly, angle A corresponds to angle F, B to G, C to H, D to I, and E to J. So make sure that makes sense to you. And then AB, the ratio of AB to FG, those are corresponding sides, BCGH, DCHI, DE to IJ. Oh, I could color those, couldn't I? That's the green. CD to HI is the yellow. BC to GH is pink. AB to FG is blue. And EA to JF is not colored, as I didn't have enough colors. Okay? So if you need to pause and just take a look at that for a minute, go right ahead. All right, example 1. Given that ABCD is similar to EFGD, so that's the big rectangle to the small triangle, and AB equals 10, well, I'm going to write that on my drawing right now. AD is 6. All right, I'm going to label that out to the side here, because if I put it in here, I'm not going to be sure what part of it it's referring to, but here I've shown that it's this whole distance here. And AE is 2. I'm going to put that on the inside because there's not much room on the outside. Find EF. So I'm going to label that with an X because that's my unknown. All right, question. Would it help to redraw this as two triangles? Maybe. Well, it would, actually. It would. But is it necessary? I don't know. I'm willing to, I'm going to do this one without redrawing it, but if you find that redrawing helps you, especially when you're learning, go right ahead, okay? So I have some corresponding sides here, AB to EF. Yeah, that's proportion. Those are corresponding sides, and I don't have like I don't have anything else that actually corresponds, but I do know that ED has to be 4, right? Because 4 plus 2 has to equal 6. And now I have some corresponding sides because this one corresponds to AD, okay? And that would be easier to see if we'd redrawn it. So I know that 10, the ratio of 10 over x to 6 over 4 is going to be equal. So x equals 10 times 4 divided by 6. X equals 6.6 repeating, which I'm going to round to 6.7. And this time I have to include units because there were units in my question. All right. Example 2. This has just got some questions for you to answer. Given that ABCD is similar to EFGH, how big is angle E? Well, looking at my diagram, I can see that angle E corresponds to angle A. That makes it 90 degrees. How big is angle G if angle C is 100 degrees? Well, those are corresponding as well, so G has to be 100 degrees. Find the length of EF. So I'm going to label that with, actually I'll just do it with, I'm going to, so EF, the ratio of EF to AB, those are corresponding sides, is going to be the same as EH to AD. And I have to use EH and AD because that's the only side that I know the measurements for in both shapes. Okay, so I'm going to rewrite this with numbers. EF, I don't know, so I'm just going to leave that as EF. AB is 2. EH is 12, and AD is 3. So EF equals 2 times 12 divided by 3, which is 8. CD, I'm going to just suggest you pause the video and try CD on your own and come back. Okay. CD corresponds to GH. So I've got that, and then I've got AD over EH. I did my triangles backwards this time. I put the different one first, but it doesn't matter as long as I still have the small triangle as both of the top ones and the big one is both of the bottom ones. That's okay. So CD, I don't know. That's what I'm looking for. GH is 10. AD is 3. EH is 12. So CD equals 3 times 10 divided by 12, which is 2.5. That makes sense? That seems reasonable. It looks like it's somewhere between the length of 2 and 3. Yep. Okay, the scale factor of image ABCD to object EFGH. So scale factor equals image over actual. So I'm going to use again this 3 and the 12 because those are the numbers that I was given. So the size of ABCD, that number is going to be the 3, and for the object, which is EFGH, it's going to be 12, so that's 1/4 or 0.25. Okay, for question F, there's actually a typo in the question. This should be image EFGH to object ABCD object. That was not good. Object. Sorry about that. So scale factor equals image over actual. This time the image is EFGH, so it's 12, and the object ABCD, the corresponding side, is 3, so our scale factor is 4. All right. Okay, let's look at our last example, example 3 on this page. Okay, given that quadrilateral ABCD is similar to EFGH, determine the scale factor, and then the lengths of X, Y, and Z. The scale factor is image over actual, and the only side that we have both pieces of information for is the BCFG. So those are the numbers that we'll use for the scale factor. So image is 20 and actual is 32. So our scale factor, that reduces to a fraction of 5/8, or we can write it as a decimal as 0.625. Okay, so that's the scale factor. Either of these is okay. Okay, now for doing X, Y, and Z, I'm actually going to do them backwards. So let's just color Z and its corresponding side. And so for Z, I have that 32 over 20 is going to equal 24 over Z. So Z equals 20 times 24 divided by 32, and that gives me an answer of Z equals 15. And that seems quite reasonable, doesn't it? Okay. Let's do Y. I'm going to do Y a little bit different, actually. So let's do y. Because the other way we can do this is we've been using the formula that scale, or scale factor because it doesn't matter, is image over actual. Actually, I guess in this case we have to use scale factor because it's just going to be a number. So this is just an algebraic expression, and if I multiply both sides by a, then my a's cancel out here, and I get that image equals scale, or actual, let's do it, let's write it the other way. Equals actual times scale factor. Okay, so when I'm in this one, I'm looking for y, which is the image, and I can use this formula where I equals a times the scale factor. So my actual for that, for the side y, is 36, and my scale factor is 0.625. Now, you can only do this if you have not rounded your scale factor. Okay, if you've rounded it, you won't get a correct answer. All right, but 36 times 0.625 gets me an answer of 22.5 for y. So that means that this one here is 22.5. And again, that seems reasonable. It's a little bit bigger than the 20 bigger. The 36 is a little bit bigger than the 32. That works. All right. Now for x, this time we're looking for the object or the actual size. So we're going to go back to our equation here, and if I divide this side by scale factor and I divide this one by scale factor, those scale factors cancel out and I get actual equals image divided by the scale factor. So the actual dimension is going to be the image divided by the scale factor. So our image size for that length is 25. We divide that by 0.625, and that gets me an answer of 40. So this is 40. And again, that seems quite reasonable. Okay. So, but if you're not comfortable with the algebraic manipulation up here, I don't want you memorizing these, because if you memorize them and you mess them up, you're hooped. Just stick with the original scale equals image over actual, and the proportions will work for all of these. They also have the advantage of using original numbers, but I did want to show you both ways. All right, go do your homework, mark your answers, do your corrections, and then there will be a quiz for you. Have a great day.